We have discussed derivatives algebraically and geometrically. One may get confused between the terms derivative and differentiation. What is the difference between derivative and differentiation? Are they one and the same? Well, differentiation is the process for finding the derivative of a function, and the derivative is the result obtained on performing the differentiation process on a function. Let's define the derivative of a function at a point. Suppose f of x is a real valued function and a is a point in its domain of definition, then the derivative of f of x at x equals a is defined by the limit of f of a plus h minus f of a over h as h tends to 0 provided this limit exists. Can we find the derivative of f of x at any point? Yes. Using this definition, we can find the derivative of a function at any point. If the derivative exists at every point, it defines a new function called the derivative of f. Formally, we define the derivative of a function as follows. Suppose f of x is a real valued function, then the derivative of f of x is defined by the limit of f of x plus h minus f of x over h as h tends to 0 provided this limit exists. The derivative of a function f of x is denoted by d by dx of f of x or d of f of x or simply f dash of x. Notice that d by dx does not refer to division, it is an operation. If we write the function as y equals f of x, we may denote the derivative as dy by dx also. This is referred to as the derivative of y with respect to x. Whenever this limit exists at x equals a, we say that the derivative of f of x exists at x equals a or f is differentiable at x equals a and we denote it as shown. This definition of derivative is called the first principle of derivative. Let's learn how to find the derivatives of functions using the first principle of derivatives. Let's first see how to find the derivative of a function at a point. For this, let's take a simple function, for example 2x minus 1 and find its derivative at x equals 1. First, let the given function be f of x. Recall that the derivative of a function f of x at x equals a is equal to the limit of f of a plus h minus f of a over h as h tends to 0. Notice that the value of a is equal to 1 in the given function here. Hence, we find f of 1 plus h and f of 1 by replacing the variable x by 1 plus h and 1 respectively in the given function. Next, since the numerator in the formula is the difference of the function values at a plus h and h, we find the difference f of 1 plus h minus f of 1 and simplify. Now, we divide the obtained result by h. Therefore, finally on finding the limit of the obtained result, we obtain the derivative of the given function at x equals 1. Next, let's take another function x square and find its derivative at x equals minus 3. First, let the given function be f of x. Notice that the value of a is equal to minus 3 in the given function here. Hence, we find f of minus 3 plus h and f of minus 3 by replacing the variable x by minus 3 plus h and minus 3 respectively in the given function. Next we find the difference f of minus 3 plus h minus f of minus 3. Now we divide the obtained result by h. Therefore, finally on finding the limit of the obtained result, we obtain the derivative of the given function at x equals minus 3. We have seen how to find the derivative of a function at a particular point. Now, let's obtain the derivative in its domain of definition. When the derivative of a function exists at every point in its domain of definition, a new function is determined called derivative function. Derivative function can be obtained for a given function using the first principle of derivative. Let's find the derivative function of x square using the first principle of derivative. Notice that we are finding the derivative function, not the derivative at a point. In the process of finding the derivative, we first consider the given function as f of x. Next, since there is a term f of x plus h in the formula, we find f of x plus h by replacing x by x plus h in the given function. Then we find the difference f of x plus h minus f of x. And then we divide the resultant function by h and simplify. Now, finally, we find the limit of the resultant function as h tends to 0. Therefore, we obtain the derivative of the given function. Find the derivative of the constant function using the first principle of derivative with respect to x. The key to solve this question is to use the first principle of derivative. First, the given function is f of x. Since there is a term f of x plus h in the first principle of derivative, we find the value of f of x plus h by replacing x by x plus h in the given function. Next, we find the difference f of x plus h minus f of x. Now, we divide the obtained result by h. Therefore, on finding the limit of the obtained function as h tends to 0, we get the derivative of the given function.